Okay, now we're going to continue with section 1.3. We're going to find missing sides and angles in right triangles. So our objective is simply that, to set up SOHCAHTOA equations to find missing sides and angles of right triangles. So for example, suppose we have this. We have a right triangle, triangle ABC. C is the right angle. And this side is 11. This side BC is 11. This angle A over here is 35 degrees. And they want us to find C, the hypotenuse. That's what they want us to find. Okay. Well, we can set up a SOHCAHTOA equation to solve for that. First of all, what we do is we look at the side they are asking us to find. Well, the side they're asking us to find is the hypotenuse. And then we look at the side they gave us, and we go from the angle they gave us. They gave us 35 degrees. Right? Well, from 35 degrees, this side is across from 35. This is the opposite side, according to angle A. So now we go back and we think, okay, opposite and hypotenuse. Which of our three main trig functions uses opposite and hypotenuse? Well, it's sine. So now we write our trig equation from that, and we write this: sine of 35 equals the opposite, which is 11, divided by the hypotenuse, which is C. And then now, of course, we do what we always do, which is solve for the variable. We have to get C by itself, and I'll show you a trick in a minute. But in order to do that longhand, what we would first do is multiply both sides by C, because then that would cancel out. And we have C sine of 35 equals 11, and then divide both sides by sine of 35. So we have 11 divided by sine of 35, which we could put into our calculator. So we take 11 divided by sine of 35, and it gives me 19.177 would be acceptable. Also acceptable would be 19.178. Remember, because we can either truncate to 3 decimal places or we can round. So truncating would give us 1.77 or 0.177, and rounding would give us 0.178. Both are acceptable. Okay. Now, there's a shortcut to this here. If we're stuck here, sine of 35 equals 11 over C. When the variable is on the bottom, the shortcut is to take this and just switch them. Isn't that what happened over here? All we ended up with, we started with sine of 35 equals 11 over C, and longhand it ended up the C and the sine of 35 just ended up switching spots. So that's our shortcut to doing this longhand work here, is just take when the variable is on the bottom, switch it with everything on the other side of the equal sign. Okay? So that's how we find a missing side. Let's do one more. Say I have this. Okay. This is 26.2 degrees. This is 15, and it says to find B. Okay, well, find B, we look again, which side are they asking us to find? Well, this angle, this side is the adjacent side, and this side across from the right angle is the hypotenuse. So we go adjacent and hypotenuse, we go cosine is adjacent and hypotenuse. So to write our equation, the cosine of 26.2 degrees equals the adjacent B over the hypotenuse 15. Now this time the variable's not on the bottom, the variable's on the top, so it's a little different than this one. Since the variable's on the top, what we really have to do is multiply both sides by 15. Those will cancel, and this we can put into our calculator. Now, just like up here, I'd accept this as your answer. Okay? At least for some things, we'll accept that. Sometimes we'll accept that. Now, we also can, of course, put it into our calculator, 15 cosine of 26.2, and we get this is 13.458, or also acceptable here would be 13.459. Either one of those would be acceptable answers. Okay, So that's how we find sides. We set up a sine, cosine, or tangent equation, depending on what they're asking for and what's given. That's how we set it up. Now, let's say we want to find angles. Okay, sometimes they'll give us sides and not give us angles. We're still going to do the same thing. So suppose I have this, where this is 13, this is 5, okay, and it says to find A. Notice we use capital letters for the angles and lowercase letters for the sides. Okay, well, if I want to find A, again I have to ask myself, what are they giving me? They're asking me for this angle, so when I'm looking over here at the sides, this side would be opposite A, and this side would be adjacent to A. So we go back to SOHCAHTOA, way back up here, SOHCAHTOA, which one uses opposite and adjacent? And it's tangent. So we write an equation, tangent of A. This time we don't know what the angle is, so we just have to use the letter A. Whereas before we had a number we put in there. We don't have a number to put in this time. So the tangent of A is the opposite 13 over the adjacent 5. Now, we need to solve this and get A equals something. A equals something. So somehow we have to get rid of this tangent. And we've been getting rid of things for a long, long time. Just to illustrate my point, when I ask you to solve 2x equals 12, everybody knows what to do. You would divide both sides by 2. The reason you're doing that is because this is 2 times x, and the opposite of multiplying is dividing. So we're doing the opposite operation in order to cancel out the 2 that's there and solving our equation. Now we have to have an opposite operation for tangent, and we also have one for sine and for cosine. And they are the inverse trig functions. And they look this way: inverse sine, inverse cosine, inverse tangent. It's always written with a little -1 that looks like an exponent. Okay, it is on our calculator. I'll show you that in a minute. So much the way that when I divide by 2, these 2's cancel out, I'm going to use tan inverse to cancel out tangent. Now, if I had cosine, then I'd use cosine inverse to cancel it. So what it would look like if I take this equation, remember, because I have to do the same thing to both sides. So this is exactly what I did here. I divided both sides by 2, not just this side. If I'm going to get rid of the tangent, I'm going to use tan inverse. I have to do that to this side as well. I can't just do it to one side of the equal sign. I have to do it to both. Now these 2 cancel, and I'm left with A equals the tan inverse of 13 divided by 5, which is something we can put into our calculator. Okay? And here's how we do that. You'll see in the sine, cosine, and tangent buttons above them in blue, or it says sine inverse, cosine inverse, tangent inverse. So we hit this blue second key up here, blue, and then tangent, and you'll see it comes up on the screen as tangent inverse. And then just type in 13 divided by 5, and that tells me that that angle A is 68.962 degrees. And we can do that with sine, cosine, or tangent, any of the 3. Okay. Good.